Water.
Nước.
Nước.
Low.
Agua.
Soy.
Shui. Mat. Pani.
Water is one of the most important things on this planet. People call water different things. Cultures have collapsed on water and cultures have been made on water. But at the end of the day, water is what is the most crucial thing to us as human beings, as in life in general. Now, in stormwater management research, we go out and sample different streams of water and we test for conductivity, which is the concentration of ions. We test for pH, which is the concentration of hydrogen ions. We test for flow rate, which is the movement of water. We test for temperature, and if you want, we test for bacteria. But when we get all these measurements, we put them in a form, and everyone in the state can look at what you put in for a certain stream of water in your area. And from that, you create trends. You know what's going on in the water. You have a story about the water. And from those trends, you identify a problem, if there is a problem. And if there's a problem, you guys have to make a solution. Now, the first step of this is to actually go out and start sampling. Let's go sampling. In order to go out sampling, you need to use different instruments to get the measurements. So this is a lab quest, and most of the instruments have this cord. And what you want to do is you want to take this cord and put it into one of the channels here. Plug it in, and then it should say what instrument you're using. So this is a conductivity probe, and as you can see, it says conductivity on it, and it'll be measuring conductivity as long as it's plugged in. This is a flow rate meter. You have to assemble it, which we'll show you how to do. And this is a temperature probe. It's a normal probe. And this is a pH probe. Now, all these things have that cord like I showed you, but this is a dissolved oxygen meter. It doesn't require a lab quest. We'll show you how to calibrate this and use all these instruments. Now, when you guys go out sampling, you need to have all these instruments with you and take all the measurements. So we typically use a bag to just put in all these measurements, these instruments, and we take this bag out sampling, and then we start measuring the water for different things. So yeah, let's go sampling.
Alright, so in this video we're going to show you how to calibrate a pH probe. So the first thing you want to do is grab a few containers. The first is going to be of distilled water, and you always want to have separate containers. You don't want to use a huge bottle of distilled water because it will contaminate it. The second one is going to be a container for your, switch these around, pH 4 buffer. And then the third one is going to be for your pH 10 buffer. Now, we do not have one of the pH 7, but that would be to check your calibrations. So the first thing you want to do is take 100 milliliters of water and pour it in, of distilled water, and pour it into each of these to make sure the concentrations are correct. So the green capsule will always have your pH 4, your orange capsule will always have your pH 10, and the pH 7 will be in a blue capsule. So we've already poured it in to make it a little easier, but you would unscrew the cap, pour it into the 100 milliliters, stir it around, make sure it's all dissolved. Then you would do the same for the 10. So what we're going to do right now is we will calibrate it. So you click right on the screen on your LabQuest, calibrate, and just calibrate now. And then it will say enter value 1. Now you always want to do the higher concentration first, so we'll do 10. And that's so it won't contaminate the 4 because it's of a, the 4 is of a lesser value. So we'll stick it right in, swirl it around, and we will enter 10. And usually you let it wait, but for our purposes, 2.49 will be okay. So then you're gonna put it in distilled water just to make sure it's all clean. Then it will say known voltage, known value 2, and you'll enter 4. Swirl it around in there. And 1.7, keep that. And then you just click OK. And so if we had the 7, which is neutral, we put it right in the 7 solution and it should read 7. But you can check it in either one if you don't have the 7. So it's reading 5.4. If we put it right in the 4, it should read just about the 4, 3.99. And that is how you calibrate a pH probe.
Thank you.
So now we will be showing you how to calibrate a dissolved oxygen meter. So first thing you want to do, there's not a lot of buttons on here. It's a pretty easy calibration. So you turn it on, and the only thing is it takes a little bit of time. So what you want to do is you're going to have to wait 15 minutes or so for it to level out, but for our purposes today, we will just show you how to calibrate it quickly. So what you're going to do is the 2 arrows, you're going to hold them down and it will say calibrate. So then you click the enter button and it will give an altitude, and that just depends on your region. For now we'll do 1, and then it will pop up, and we are doing it in percent, but some other places do it in milligrams per liter. And then if you go and do a sample, you're just going to unscrew this part right here and it will pop out like this. Stick it in the water. It also reads the temperature as well, so you don't even need a temperature probe. And that is how you calibrate a dissolved oxygen meter.
I'll be recording the data on my phone. You have to write the date, the name of the site, and what the weather's like. I'll be recording the dissolved oxygen, the temperature, pH, conductivity, and the flow rate.
Alex and I are going to take the DO reading, and you want to make sure that when you're using this instrument that you wear the safety strap in case anything happens.
It is imperative for the meter to be fully submerged and for the cord to stay dry. Well tested.
$124.7.
Okay. So this is a lab question. It's used to measure the temperature, the conductivity, and the pH. This is the pH probe. You always have to keep this in the buffer solution to keep the probe moist. Here we have the conductivity probe. Here, you want to talk about this?
This is basically a setting. You have 3 different ranges from where you can measure the data, and over here we typically keep it from 0 to 2000. However, it depends on your water, how much you want to do it as, and you should ask your teacher what he would prefer it as.
And here we just have the temperature probe.
When you are down here, you want to make sure you don't push your partner. And if you do, you want to make sure he can swim.
Okay, so the temperature is 0.2 degrees Celsius. The conductivity is 130. Finally, the pH. Take the buffer solution. You always want to make sure that you don't lose this.
Don't do it.
The pH is 9.4.
So this is a flow rate meter. It tests the flow rate of a body of water that is moving.
Then you want to make sure that this end is pointed upstream.
Yeah, damn, it's cold.
And also that this is sticking straight up and down, because if it's at an angle, it's not going to get an accurate reading.
It is 0.032 meters per second.
All right.
You guys, how many? Oh, are you?
Cord. Okay, Becky, you want to give it a shot? Let's get out of here.
That was fun.
That was fun.
It's really cold though.
Yeah, it is really cool.
It's much more fun in the summer.
Yeah. No, we love helping Bangor. It's super cool to, I don't know, like be part of this. And it's like, it's become like more of like prominent in our community and like even statewide. So we hope that you guys will enjoy it as much as we do. It's a newer outreach program that the university
You should go back and forth. Just.
and so it's been around for a couple years now, and we're excited that it's going more public. We've been able to help our community through the data and research that we've done, so we hope that you guys will be able to do that too. Add me on IG, Snap,
So you can also go out and test for bacteria, and you'll have little baggies, or sometimes we'll have containers. You put on your gloves and you'll get a small sample of it. There will typically be a line on the bag or the bottle to where you want that sample to be, and then you'll bring it in the lab and we'll show you guys how to test for bacteria.
So this is our sample from the stream that we collected, and to close the bag you just swirl it like this, and then when you bring it back to the lab to collect your sample, you open the bag with the two tabs on the sides, and then you just dump it in 100 milliliters. So it's approximately 100 mils. Then you add the media. And then you swirl it until it dissolves. Okay, and then we'll put it in a tray. And then we have to be careful not to touch the sides of the tray so it doesn't get contaminated. And then you pour it in. And you put it through this machine called the Quanti Tray Sealer. So then it goes through, right? And then when it comes out, it'll be sealed like this. And then you just put it in this incubator for about 24 hours. And when they come out, they should look something like this if they're contaminated.
And if they're yellow, that means they have coliforms. And then if you put a UV light over it and it glows, it means there's E. coli.
Thank you for watching this video. Stormwater management research is a great way to be part of the community and simply have fun with new people. You guys will have the opportunity to make new projects that will help the world in a positive manner. I'll see you guys in the summer.